Problem 72. Find the derivative of h2 of x equals square root of x plus 3 by the limit definition of derivative. So recall that the limit definition of derivative is that h2 prime of x is the limit as delta x goes to 0 of h2 of x plus delta x minus h2 of x divided by delta x. So for this first part, we're going to replace all the x's in the original function with x plus delta x. So this gives us the square root of x plus delta x plus 3. And then we're going to subtract the original function, so we subtract square root of x plus 3. And then we're going to divide all this by delta x and take the limit as delta x goes to 0. So we have radicals on here, so the idea is to multiply both the numerator and denominator by the conjugate of whatever our radical part is. So we're going to multiply by radical x plus delta x plus 3 plus radical x plus 3 on both the numerator and denominator. So we multiply the denominator by x plus delta x plus 3 plus radical x plus 3 as well. Now when you multiply this through, if we distribute the top out, we multiply these together. This gives us the limit as delta x goes to 0. The square root here and the square root here, since the insides are the same, will cancel to leave us x plus delta x plus 3. If we look at the outside and the inside terms, this is a conjugate, so these will cancel out. And then we multiply the last terms together, we're subtracting x plus 3, because again the radicals cancel. In the denominator, there were no radicals to get rid of, so there's no need to FOIL this out. There's no need to multiply this through. So we'll leave it as delta x times the two square roots, x plus delta x plus 3 plus radical x plus 3. Now in the numerator, I see that we have an x here and we're subtracting an x here, so they cancel. We've got a positive 3 here, and we're subtracting a positive 3 here, so they cancel. That means all we're left over with on this, we've got our limit as delta x goes to 0 of delta x divided by delta x times those two radicals, x plus delta x plus 3 plus radical x plus 3. And now these delta x's can cancel, and once the delta x's are gone, we can now evaluate our limit by direct substitution, and this gives us 1 over square root of x plus 3 plus the square root of x plus 3. And this we can simplify to being 1 over 2 square root of x plus 3. Now let's quickly check this by doing the power rule. We can rewrite the original function as x plus 3 to the 1/2 power. And then taking the derivative of this says that h2 prime of x is, by the power rule, 1/2 x plus 3 to the negative 1/2. And then if we use this, evaluate this negative exponent, we can write this as 1 over 2, 1 over square root of x plus 3. And that matches what we found by using the limit definition.